All right, y'all, today we're going to look at lateral surface area of pyramids. So in our previous lesson, we talked about lateral surface area of prisms. So in case you forgot, our faces is what we're looking for. We talk about the lateral because lateral means the sides. So the faces are the sides that are around this three-dimensional shape. So for example, when we see this, we can shade this part, which is the base. So I always suggest to shade the base first, so then that way you can see that everything around it are going to be the sides around that base when it's three-dimensional. Or when we have it as the net, if we have this part as the base, you can see that those lateral faces are around that base. Again, with a pyramid, if we were to fold these two triangles up and then fold these two triangles up, they're going to meet right here at this vertex. So this is why a couple lessons before this, we talked about just distinguishing between the fact of prisms and pyramids. So the lateral faces are going to be the faces around the side of that pyramid, and again, your faces in a pyramid are always going to be a triangle. Your base could be any shape, but your faces are always a triangle because you're folding up and meeting at that point called the vertex. So we're going to find the area of all those triangles. So the lateral faces do not include the base. And there's only one base in a pyramid because your base is always across the vertex. You have two bases in a prism, one base in a pyramid. So on a pyramid, those lateral faces are always going to be triangles. And again, the reason why they're triangles is they're directly across this vertex. I'm sorry, not the triangles across the vertex, the base is across the vertex. So when we're folding up, we're meeting at that vertex. So the lateral surface area itself is when you find the total area of all those lateral faces. So first, we're going to identify the lateral faces, find the area of each of them, and then add those areas together. So right here is my base, and that base is always across that vertex. So if it helps you to draw an arrow across it, you can see like that. So right here we see that the base is a rectangle because we have 4 and 5/10 by 3 and 5/10. This base right here is a triangle. Okay? So if your base is a triangle has 3 sides, so that means you're going to have 3 faces. If your base is a rectangle has 4 sides, that means you're going to have 4 faces or 4 triangles. So these are what they would look like if they were unfolded. Okay, so here's the actual three-dimensional, and this is what's called the net when we unfold it. So this one's unfolded, so this was the base right here, what I shaded in green, and then we can see that we have these lateral faces. Okay, so we can see right here, I'm going to label these with our faces. We're going to find those lateral faces, find the area of each one, and then add them up. So if I can call this face 1, I can call this one face 2, face 3, and face 4. And I'm just abbreviating with F for face. Okay? So if you stop and think about it, if you look right here, because this is a rectangle, this is 3 and 5/10 feet. So across from it is parallel and congruent in a rectangle. So that means that this is also 3 and 5/10 feet. And then this one right here of this triangle is 4 and 5/10. So that means that this distance is 4 and 5/10. Because remember, in a rectangle, your opposite sides are parallel and congruent. So that's something to think about. So that what that means is that face 1 is the same dimensions as face 3. And I'll use that blue to kind of help us out. We'll say face 2, that triangle, is the same measurements as face 4. And we know that because of those distances across from it. Okay? So really and truly, if you kind of think about that, instead of finding an area of 4 triangles, you can actually find the area of this triangle and the area of this triangle, and then we can just double them because these two are congruent and these two are congruent. So let's see what we can do. So if I say the area of face 1 or face 3, either way we could do that, we can say it's a triangle. So our area formula is base times height divided by 2, or you can say 1/2 base times height. Remember, multiplying by 1/2 is the same thing as dividing by 2. So the base of face 1, or even face 3, because they're the same amount, is 3 5/10, and the height of that triangle is 5 feet. So you're looking at one face at a time. So base times height divided by 2. So normally you're going to have to do this without a calculator, but just for time purposes, we're going to go ahead and use a calculator. But just remember, if this were a star test or a classroom test, you'd have to do it without. So 3 5/10, base of that triangle times the height of the triangle, and then divide by 2. You're going to get 8 7/5 square feet. Okay? So what I'm going to put right here is I'm going to say 8.75 and circle it to say that's the area of that triangle. That's also the area of this triangle right here. Okay? So face 1 and face 3 are congruent triangles. So now let's look at face 2 or face 4. So if we look at our triangle for face 2, the base of that triangle is 4 5/10 feet, and the height is 6 feet. So you always want to start with your formula, 1/2 base times height, which is the same thing saying base times height divided by 2. So if I said my base of that triangle is 4 5/10 times the height of that triangle is 6. So base times height divided by 2. So we can say 4 5/10 times 6 is 27. And then we're going to divide that by 2. Dividing by 2 is the same thing as multiplying by 1/2. So that gets me 13 5/10 square feet. So the area of this one is 13 5/10, which means face 4 is also 13 5/10. So we identified the lateral faces. That was my first step. Because my base was a rectangle, that means I'm going to have 4 triangles because it's a 4-sided figure for my base. We found the area of each of the lateral face. Now we're going to add them all together. Okay, so because I have 4 faces, I should be adding 4 numbers. So I have 13 5/10, 13 5/10 for face 2 and face 4. Then I have face 1 and face 3, and we can add those all up. Okay, put a 0 as a placeholder right here. We'll get our final answer. So 0 plus 0 plus 5 plus 5 is 10. 5 plus 5 is 10. 7 plus 7 is 14, so that's 24 plus 1 is 25. Bring down the decimal, so that's 16, 17, 18, 19, 20, 21, 22, 23, 24. So 2, 3, 4. Okay, so the lateral surface area, that means the area of all the lateral faces, all 4 of those triangles, is 44 50/100, or you can say 44 5/10 square feet. Okay, the name of the figure is what the base is. So the base is a rectangle, so this is a rectangular pyramid. 2 reasons why we know it's a pyramid. 1 base, and all the faces are triangles. Remember, a prism has 2 bases, and all of its faces are rectangles. Okay, so let's look at the next one, and then we'll get you guys some practice problems. So if you look at this one, you always want to label the base first. And they're telling us that this 6 inches right here is this distance right here. If they don't have the other ones labeled, that means that these are equal. So this is 6 inches, and this is 6 inches. Okay? And if you're confused on that and need some more help, just make sure you ask your teacher. But that's how we're going to look at it this one, okay? So these 3 triangles are all the same amount. So if we call this face 1, face 2, and face 3, these are actually equilateral triangles. So really, we can find the area of this first one, and that's going to be the same as this area the same as this area, so we could add them up 3 times or just multiply by 3. Kind of something to think about. Okay? So if we look at this triangle, we can also see, well, they didn't tell me what this height is, but they tell me this 5 inches right here. So if we were to fold this over, it overlaps. We're going to say that the height for this one is 5 inches. So just something to think about. Be very careful when you're looking at the pictures, and of course ask your teachers if you want to make sure before you don't use the wrong number. So the area formula for a triangle is base times height divided by 2. Originally you're going to see on your formula chart 1/2 base times height, but I'm going to encourage you to do base times height divided by 2 because it's a little bit easier instead of multiplying by a fraction. Remember, when you multiply by 1/2, it's the same thing as dividing by 2 anyway. So the base of that triangle right here was at 6 inches, times the height would be 5 inches, and then we're going to divide by 2. So 6 times 5 is 30, 30 divided by 2 is 15. So the area is 15 of all of them. Okay? Well then, if I'm going to add these all up, I could say 15 plus 15 plus 15, because I need to add 3 numbers, the 3 faces. But 15 plus 15 plus 15 is the same thing as saying 15 times 3. So 3 times 5 is 15, 3 times 1 is 3, plus 1 is 4. So we're not including the base. Okay? When you want the lateral surface area, you only want the faces only. So the base of this was that shape in the middle. That's the other way too with pyramids. When they're unfolded, your base is going to be in the middle. And that's a triangle, so this is called a triangular pyramid. And each of the faces was worth 15 inches, so 15 plus 15 plus 15 is 45. So my lateral surface area is 45 squared inches. Okay? Where you have to be careful on these is if you do the math right, but you forget to divide by 2. So like on this one, if you thought it was 17.5, and then you thought this one was 27, so if you accidentally did 17.5 plus 17.5 plus 27 plus 27, I bet that would be a trick answer because they know that sometimes y'all forget to divide by 2. So this is why we want you to start with the formula, then substitute your numbers, and double check your work. Same thing over here. If you forgot to divide by 2, 30 plus 30 plus 30, if this were multiple choice, 90 would have been a trick answer. Okay? All right, guys, so let me know and your teachers know if you have any questions as you're working on your class assignment, and good luck.